Goal for this slot is to use inversion to show that you don't need a ruler to do compass ruler constructions. Okay, so I'm gonna first sort of review some basics for inversion. I guess this is mainly for Aaron, and then we'll go into sort of compass constructions. Okay. And then we'll just carry out the program. Hopefully you guys will do most of the work because I think it's within your ability. And it's definitely some of the parts, it's probably easier if you try to figure it out yourself than if you read what they say. I mean, reading what they say is kind of easy to understand and it gives you a proof, but to really understand why it works, I think you have to sort of think about a lot of it yourself. Okay, so what is inversion, okay? So inversion about a circle, okay? So you fix a circle and it's got center O and radius R, okay? And what it is, it's a transformation of every pair of points on the plane, okay? Except for the center of the circle. So what it does is it pairs up, so it's an involution, okay? So it's a function from the plane minus the origin of the center of the circle to the plane without the center of the circle. Okay? And it's an involution. Now we usually call like f of p, we have like equals p prime. That's how we denote it. So, and the definition is given like this. So if p is inside the circle, for example, okay, it'll go outside the circle, okay? And so since it's an involution, the outside will go inside, okay? And the rule is that OP times OP prime is equal to R squared. Okay? So you can kind of see that the power of a point is related, right? So it's sort of like the power of O with respect to P and P prime is constant no matter what P is, okay? So that's the definition. So there's lots of nice properties that this has, but I'm only going to go over sort of the basic ones that we need, okay? So the properties that we need today are that, so the property that we need is that lines, so lines means straight lines, yeah? Lines not through O. So obviously lines through O just go to lines through O, right? Lines not passing O become circles passing O. Okay? So this is the main claim that we'll need. Okay, maybe we can brush over some other things along the way, but the main thing we need to know is that lines go to circles, right? And so can you see that lines going to circles is kind of like ruler going to compass, yeah? So why would lines go to circles, okay? So let me just erase that. So if you look at your circle O, right? And you have like a line. And it's going to look basically vertical from some perspective because the circle is symmetric, right? So the claim is this line, okay, yeah, the image of every point on this line under inversion will form a circle that goes through O, okay? And there's other cases too, obviously. The line could intersect or it could be tangent. So let's look at the case when it's just outside the circle, right? See, we know that this circle is going to be entirely inside this circle, right? Because the outside points go inside. So we're kind of looking to be a point like a circle like this, okay? So the way you kind of prove that, you can prove it like this, is so you can take the perpendicular distance of the line, right? And so then this could be P, this is like P prime, okay? And you can take another point on the line, Q, and then Q prime will be somewhere here on this line, right? So Q prime could be even closer to, the further away it is, the closer it is to the center. So it'd actually be here, okay? Q prime, okay? And I guess we verified it directly before, but I want to kind of do it another way since we're a little bit more advanced now. So can you see the point is the power of O with respect to Q prime and Q is the same as the power with respect to P prime and P, right? So this means that Q prime Q P prime is cyclic, right? So for circles, the power of a point is constant no matter where you take the secant or whatever. And the converse is true. So if the power is constant, then the 4 points are cyclic, right? So if we know these 4 points are cyclic, then we know this angle is 90 degrees, right? And so we see that actually any point Q inverts to a point on the diameter on the semicircle OP prime, okay? And on the other side it's going to be the other semicircle. So this whole line goes to the circle with diameter OP prime. Okay? And obviously vice versa, okay? Because this is going to be cyclic and these two angles are 90 degrees. So if and only if this is 90 degrees, if and only if that's 90 degrees. Okay? I mean, you can consider the other cases yourself pretty much, but I think it's good to highlight the relationship between the line and the circles. It's probably the radical axis. Okay, so look at this. If the line goes through the circle, get the same kind of argument, right? So this will go to a point outside. So you might have so again, these 4 points are cyclic, so this is a 90 degrees, yeah? And you know that the points on the circle are fixed, yeah? Because this is just this squared equals the radius squared, so they get fixed. And so you know that the circle actually passes through the points of intersection, okay? The power of a point with respect to, you know, like the circle we want to make as a circle is Q prime, P, right? So the power of O with respect to that circle, yeah? It makes sense because both OQ and OQ prime is equal to R squared, right? You know, and if it's part of this point outside the line, yeah, if it's that line, and it goes here, right, then so these 4 points are cyclic again, okay? And so that's going to make this also 90 degrees, yeah? So that's 90 degrees. So you get this circle here, okay? So I hope Aaron's listening because this is mainly for him. Yeah, so in this case, the circle actually has radical axis to the line, okay? The inverting circle and the image circle has radical axis the original line, okay? And I guess there's also the case that it's a tangent. But it's more important just to be aware of them than to necessarily go through them because we know sort of how it's working now, right? The tangent, that point gets fixed, and this point goes to this point, say, okay? And so I guess you don't have the 4 points, the cyclic thing anymore. But maybe this is a more obvious angle chase. So you get this angle here is equal to, so this is 90 minus that angle there. Maybe that's the one. Oh, I guess it's still a power of a point. It's just it's a tangent now, right? Yeah. Maybe this one we could do directly to exhibit how it was done directly. So we have this distance here squared. So r squared is equal to q. So this is q prime. So it's OQ times O Q prime O is equal to R squared. Yeah, so these triangles are similar, yeah? So OQ on R is equal to R on OQ prime, which means triangle so this is P. OQP is similar to triangle. Okay, what's the correspondence here? OPQ, yeah? O this is OPQ prime. Okay, so that makes this angle 90 degrees. And so again, it's a semicircle with diameter of the radius. Okay, so the point of this is lines become circles through O. Circles through O become lines. Okay? Okay, so now that that's done, let's outline what the program is, okay? So if you remember last time, we were talking about constructing points with a compass and ruler, right? What you have is you have a ruler is you join 2 points together, right? And a compass is you have like 2 points, you make one of them the center, and you draw a circle, okay, with a compass. And the points that you construct, these are by definition the constructed points, okay? So this process that continually constructs these points, so we're saying points are called constructible if they can come out of this process, given some initial points. And they're not constructible if they can't come out of this process, okay? And what we want to go through today is that the ones that are constructible, okay, can be also obtained if we never had a ruler at all, okay? So if you just had points, okay, so if you just kept using a compass, so you draw that circle, for example, and then you draw this other circle, you can draw circles like this. You can use that as the radius and draw another circle. Okay, so if you only use the compass, okay, then you would be able to obtain the same points, but maybe with a little bit more work, but you'd still be able to get them, okay? And so, we know that there's basically 4 cases, right? There's 2 lines going together, a circle and a line intersecting, okay? And 2 circles intersecting, right? Those are the kind of points we can construct. And the plan is to show 2 things, okay? So inversion. So the main things which we want to need to show for this to work can be done with just a compass. Okay, so that's 1. 2 is, so what else do you think we need? So if we have inversion, right, and it can be done with just a compass, then you can kind of see if we can invert lines to circles, then the stuff that we had using the ruler can now be turned into stuff we got just using the compass, right? Okay, but what else might we need? Would that be enough? So if we can do inversion with just the compass, we can turn that line into a circle. So we can kind of convert these situations to each other, right? And then this becomes sort of 2 circles as well. But there was one thing when I first looked at this that made me think it might not work as stated. Can you think of what it is? I've kind of forgotten it since then, huh? So like, for example, how would you construct these points, yeah? So, you draw a circle. And you have another point, say, on the circle. Or even just another point somewhere. And you draw a line through it, yeah? So if we can carry out an inversion, we can get this circle to do that. We can turn that line into a circle. Yeah? But I guess to properly do that, well, at least it seems like it would be very helpful if you actually could find the center of that circle as well, right? Does that make sense? Because if you just have the circle, how do you like to get the 2 points here, right? You have to draw the circle with a compass. Okay, so maybe there's a little bit better motivation for this. I can't quite remember what it was when I did it. Like I had this for last week, but you can see it'd be very convenient to find or construct circle centers with only a compass. Okay. Okay, so let's try and go through how these two things can be done. Okay, and then once we see that they can be done, we'll go through the 4 cases and see how those 4 cases might be done. Okay, and then we'll see that you can actually do it with a ruler. Okay, so a little bit on the history. So I didn't go too far into the research in the history, but I just kind of noted what I saw as I did it. I got a lot of this from Wikipedia, and this was attributed to like, so it was like Mo, and then it's like Mascheroni, and then Adler, okay, and it was like 1672, 1797, and 1890. I guess I noted, so this seemed to be the earliest one, and then maybe it got lost or something, and then this one came about. I don't know. And this one, I think I noted this one because that's when the inversion came into it. Okay, and so again, you can see how like results can be known. Okay, they can be known, but it might be still inaccessible to us. Like, I mean, you'll see that we can get this done in a day with inversion. Okay, but before maybe it would take ages, and it might not even be sure it's right. Okay, so this advancements in technology is really important. Okay, so this is where I guess inversion came about. Maybe